So welcome back class 9th students in our chemistry class, and we are dealing with the same chapter, that is water, and we are in our lecture number 4. So today we are going to study about basically we will know how to calculate the determination of or calculation of solubility of any saturated solution. Then we will have some idea of solubility curves and some anomalous expansion in the solubility curve of some hydrated salt. We will take one example. Then and further related topics we will go on continuing with it. Now, dear students, first thing is the solubility, determination of solubility. Now, determination of solubility, all of you must be knowing as far as solubility is concerned, and there is a solvent which is taken as a 100 gram, and in it a saturated solution is being made. So now in our case, in this it is given in a book also, the solute is taken. First of all, we take a distilled water, 100 ml or 100 gram, whatever it is, we take water. Then what we do, we add solute. In our case, it's potassium chloride, that is KCl, and we stir it. So unless and until we reach that point that no more potassium chloride is being added to it, we go on stirring and we go on adding. So we get a saturated solution. Now to this point we have reached. Now how we will calculate the solubility after this, I will let you know. For that we have to take one evaporating dish. One evaporating dish is required, and step by step we will see how we will calculate the solubility. Now we have prepared a saturated solution of KCl, that is potassium chloride, by adding and stirring it till no more solute is being added. That concept is clear. Initially we have taken 100 ml of distilled water. Now we have saturated solution of KCl. Now we take evaporating dish. Let the weight of this evaporating dish be m gram, or you can say m, right? So weight of the evaporating. Now what is the next step? You have to pour that saturated solution or place the saturated solution on the evaporating dish. Pour or place the saturated solution on evaporating dish. Evaporating dish I am writing by ED, short form, evaporating dish. And weight, suppose it comes M1. So here, to give you a clear understanding, I am writing in bracket that the saturated solution, the M1 is the weight of evaporating dish plus weight of solution. This is M1. Yes, students, it is clear now? Because we have poured or placed that saturated solution on this dish, and we have weight. So it includes the weight of evaporating dish plus weight of solution. Now we have to heat it. Heat the evaporating dish or the solution placed on evaporating dish till it dries or till it evaporates, and weigh it. Till it dries or till it evaporates and weigh it. So residue बच जाएगा. We will heat it, and heating, the process of heating is given in a book, that water bath is to be done. We have to heat it through water bath. पहले water और फिर उसके ऊपर evaporating dish रख के, so it doesn't comes out when it becomes dry. It doesn't sprouts, you can say. Now you have to wait it, it becomes M2. Now it becomes M2. What becomes M2? That the weight of the residue or the leftover plus, so what is that residue? What is that leftover? That is the solute. So now this M2 means weight of evaporating dish plus weight of solute. I think this point is very important. Is this clear to you? That this is weight of evaporating dish, so weight of solution, and weight of evaporating dish plus weight of solute is equal to M2. Now we have M1, M2, and this concept is very much clear. What is the weight? M1 contains the weight of evaporating dish plus weight of solution, and M2 contains the weight of evaporating dish plus weight of solution. Sorry, weight of solute. Now, if you want to find the weight of solute, the weight of solute is equal to, this is one equation, or you can say here we have weight of solute. For finding weight of solute, we have to subtract here the weight of evaporating dish. So this is M2, and we can minus M, so we get weight of solute. It's very easy. Then again, what we else can get? Weight of solution we can get from this, from the above informations. So weight of solution is equal to same pattern. This combined weight is M1, and if we subtract the weight of the dish, evaporating dish, so we will get the weight of solution, M1 minus M. Now we can get the weight of solvent also, because we know this. Since I am taking each and every step to make everybody understand the process. So since weight of solute plus weight of solvent is equal to weight of solution, and we have two things here known. Solute is known as solution is known. Therefore, weight of solvent is equal to weight of solution. Yes, students, see, weight of solution, weight of solvent is equal to weight of solution minus weight of solute. So weight of solution is equal to how much we have calculated? M1 minus M. Minus, you put bracket, because there is two, we have expression, in the expression we have two variables. So weight of solute is M2 minus M is equal to, we open the bracket, so M1 minus M, this becomes minus and minus becomes plus, this cancels over, this is equal to M1 minus M2. So here we get weight of solvent also. Therefore, what is solubility? Therefore, we can get solubility. Solubility is weight of solute M2 minus M from the formula upon weight of solvent M1 minus M2. All these are in grams into 100. As we know that solubility is weight of solute upon weight of solvent, all expressed in grams into 100. And so this is the expression for the solubility. So this is the complete step. And what is the main thing? That all these happenings or all this process is at fixed temperature, that is T degree Celsius. Whether we cannot change the temperature, that T degree Celsius, or at room temperature we are doing all the things. When we prepare the, what we do all the things? When we prepare the saturated solution. So don't confuse with it, when we have heated it, so this T degree Celsius is while for preparing the saturated solution. So this is the expression for the solubility. Now we will study about solubility curve. Now we have to study about solubility curves. So what is the solubility curve? When we plot a graph of the different solubilities at a particular solvent with respect to temperature, then the graph or the curve or the line which we get during the plotting in x-axis and y-axis, along x-axis and y-axis is known as solubility curve. So what is solubility curve? That solubility depends on temperature. So at a particular solvent, for a particular solvent, different solutes have been added. Now we check by increasing and decreasing the temperature what effect it does have on that solubility. So this is known as, this plotting along x-axis and y-axis is known as solubility curve. So dear students, we have seen it's given in a book also, very well given, and in the y-axis we have plotted the solubility and the x-axis we have taken the temperature. So, and we here the temperature is being increased from 0 to 20, 30, 40, and from here solubility 0 to 20. Now one thing, we have calcium sulfate, potassium chloride, sodium chloride, potassium bromide, potassium nitrate. Now you can see, if you study this graph, suppose this is starting from here 0 initial. So means in the initial phase at 0 degree Celsius its solubility was 0. But in some graph you will see that they have already have some solubility. Means what does it mean? What does it signify? It is starting from here, means round about 70 the solubility. So at 0 degree it signifies that, it means that at 0 degree temperature, that 0 degree Celsius temperature, it also dissolves. Means it has the capacity, the solute has the property to dissolve in cold water also, or you can say at 0 degree Celsius. That it means that. And when you increase the temperature, see, this increases and then decreases because it is a hydrated salt. Potassium sulfate, slight increase. Potassium chloride, sodium chloride, very little increase. And if you see that potassium nitrates, see that it shoots up. It shoots up, means that is a rapid increase in the solubility. Sodium nitrate also has a rapid increase in the potassium bromide. But if you say the sodium chloride, if you plot different, so you will observe that there is a very slight increase in sodium chloride. So this is studying different. We have taken so many solutes, different solutes, and we are studying their behavior, how they behave when the temperature is raised. Now one important, here we are, I have taken Glauber's salt, anomalous solubility of Glauber's salt. So this is very important, dear students. You must cram it and you must practice it, the solubility curve. It can give you so many questions, or directly graph can be asked. So if you say that Na2SO4 10H2 is Glauber salt, it increases till 32.8 degrees Celsius or 36. Both temperatures I have written because in some books it is given 32.8 degrees Celsius and in your book it's 36.36 degrees Celsius. So you can take 36 degrees Celsius also, no problem. Okay, it's something varies from book to book. So you may take from your book data 36 degrees Celsius, there is no problem in it. So Na2SO4 there is increase and then there is a slight decrease when we raise the temperature. So this is the point, critical point, 32.8 degrees Celsius. Why? Because it is, what is the reason? The reason is that before 36 degrees Celsius, it is hydrous, means it has 10H2O. And after this temperature, it loses its water of crystallization, therefore it is showing this behavior. And one important thing was not given in your book, anomalous expansion of water. So I didn't went for the explanation because it was not in the syllabus. Hope you will study in further classes. So that also gives the explanation. And then this was all about the solubility curves and this. And then we have to study about various factors affecting the solubility, or the factors on which solubility depends. So you have studied in 8th class, also we have discussed the size of the solid particles. The lesser the size of the solid particles will be, so what will happen, solid particles are lesser, So they will get a chance to expose to all the solvent particles. Being bigger size, they will not get a chance to be exposed to all the, and being a smaller cell, they get the surface area, the whole volume or the surface area is, it gets a chance to expose itself to the solvent. So smaller the size of the solute particles, greater will be the solubility. Then we have very well that temperature factor, pressure factor that we will study, and you might be knowing that solubility of solids, they behave in a different manner. With increase in temperature, they generally increases, but solubility of gases and liquids, they decrease with increase in temperature. As you have the best example is of the soda fizz or cold drinks. When you open the cork, pressure decreases. Then we have to study about the Henry laws also. So now this was up to the main conceptual part. Now we have all the theoretical parts, and one by one we will finish. And my suggestion is that please go through the theoretical part, have that method, have that self study by yourself, so that it will be clear to you. And also you have studied it in 8th class, and it's very easy. So go through it. But yes, I will also cover all the topics. There is no doubt in it. So that's all for today, dear students. Thank you very much.